Welcome back to G Fun Facts Online. Today we are diving deep. Literally, we are going 4,000 meters down to the bottom of the Pacific Ocean, to a place that looks like the surface of another planet. This is the Clarion-Clipperton Zone, a massive fracture in the Earth's crust that stretches 4,500 miles between Hawaii and Mexico. For a long time we thought this place was a graveyard. It is pitch black, crushing pressure, near freezing temperatures. The only food comes from marine snow, the dead leftovers of plankton drifting down from the sunlit world miles above. It was assumed to be a biological desert where life barely hangs on. But scattered across this endless plain of mud are trillions of black potato-sized lumps. They look like charcoal briquettes. These are polymetallic nodules. And for decades, mining companies have looked at them and seen dollar signs. They call them batteries in a rock because they are packed with nickel, cobalt, and manganese, the exact metals we need to power electric vehicles in the green revolution. But in 2024, a discovery was made that changed everything. It turns out, calling them batteries wasn't just a metaphor. They are literally batteries. And down there in the dark, where photosynthesis is impossible, these rocks are doing something that science said should happen. They are making their own oxygen. This is the story of dark oxygen, a discovery that challenges what we know about the origins of life, creates a massive problem for a trillion-dollar industry, and forces us to ask if we are about to destroy an ecosystem we haven't even begun to understand. Science usually doesn't start with someone shouting Eureka. It usually starts with someone looking at a screen and saying, "That is funny." For Professor Andrew Sweetman of the Scottish Association for Marine Science, that moment happened back in 2013. Sweetman was leading an expedition in the Clarion-Clipperton Zone. His job was to establish a baseline. Before mining companies could come in and start harvesting these nodules, scientists needed to know what was living there and how the ecosystem worked. They used benthic landers, big robotic platforms that sink to the seafloor and drive metal chambers into the mud. These chambers seal off a small patch of the ocean floor, so scientists can measure what is happening inside. The rule of the ocean is simple. Oxygen is consumed, not produced. Animals breathe, bacteria rot things down. In the dark, oxygen levels in a sealed box should drop over time. But when Sweetman's sensors sent back their data, the line on the graph didn't go down. It went up. He told his students to put the sensors back in the box and ship them to the manufacturer, because they must be broken. There is no light down there. You cannot have photosynthesis. Oxygen appearing out of nowhere is impossible. The manufacturer checked the sensors. They were fine. So Sweetman went back, he used different sensors, he got the same result. He used a completely different chemical method called Winkler titration to double-check the electronics. The result was the same. For 10 years, Sweetman sat on this data. You have to understand, in the scientific world, publishing a result that claims oxygen is being created in the dark without an explanation is career suicide. It sounds like magic, not science. It wasn't until 2023 that the pieces clicked. Sweetman was talking to Franz Geiger, a chemist at Northwestern University, who had been studying how rust and salt water can generate electricity. They wondered if the nodules themselves were the cause. They took some of these nodules into the lab, put them in simulated seawater conditions, and touched probes to their surface. The multimeter screen flickered. A single nodule registered almost 1 volt. That is basically a battery sitting on the seafloor, and the seafloor is covered in them. They are touching each other, potentially acting in series, boosting that voltage even higher. So how does a rock become a battery? It comes down to how they grow over millions of years. These nodules grow incredibly slowly, just a few millimeters every million years. They are built up in layers, like a jawbreaker candy, made of iron and manganese. But the chemistry is different on the top and the bottom. The top of the nodule is exposed to the open ocean water, where metals like iron precipitate out. The bottom is buried in the mud, where the pore water is rich in manganese and nickel. This difference in chemical composition between the top and the bottom creates an electrochemical potential. It turns the nodule into a charged electrode. And when you have enough charge in seawater, something amazing happens. It is called seawater electrolysis. The electric current is strong enough to rip water molecules apart. It splits the H2O. The hydrogen drifts off, and the oxygen is released into the water. This means the ocean floor is literally sizzling with a weak electric current, constantly bubbling out microscopic amounts of oxygen. It is a planetary-scale battery that has been running for eons, completely unnoticed by humanity. This changes everything we thought we knew about the deep sea. We used to think the animals down there were just barely surviving, suffocating in a low-oxygen environment. But now we know the Clarion-Clipperton Zone is actually a treasure trove of biodiversity. We have found over 5,500 species there, and 90% of them are new to science. And these aren't just worms in the mud. Take the gummy squirrel. It is a sea cucumber, but it looks nothing like a cucumber. It is bright yellow or purple, nearly 2 feet long, with a huge sail-like fin on its back and a long tail. It roams the seafloor, vacuuming up sediment. Then, there is the Casper octopus. It is a ghostly, pale little octopus that doesn't have pigment. It lays its eggs on the stalks of dead sponges that grow attached to the nodules. The mother octopus wraps herself around the eggs and guards them. She never leaves. She slowly starves to death over years to ensure her babies hatch. Why does the oxygen matter to them? Well, scientists had always been puzzled by why the sediment in this zone was so oxygenated. They thought maybe currents from Antarctica were bringing it in. But now, it looks like the nodules are a local life support system. These animals might have evolved to depend on this dark oxygen. There is chilling evidence for this. Back in the 1980s, a mining test dragged a dredge across the seafloor, plowing up the mud and removing the nodules. Scientists went back to that exact spot 30 years later. In most ecosystems, 30 years is enough time for recovery. But in the tracks of that dredge, nothing had returned. It was a dead zone. The tracks looked fresh, like they were made yesterday. If the nodules were just rocks, just a place to sit, animals should have moved back onto the rocks that were left behind. But they didn't. This suggests that when you remove the nodules, you are not just removing the furniture, you are turning off the oxygen. You are asphyxiating the microbiome that forms the base of the food web. This brings us to the conflict. We have these amazing creatures and this new scientific phenomenon, but we also have the human need for energy. A single polymetallic nodule is packed with the metals we need for batteries: manganese, nickel, cobalt, copper. The concentration in these rocks is often way higher than what we find in mines on land. The U.S. Geological Survey estimates there is more nickel and cobalt in this one zone of the ocean than in all known land reserves combined. Enter the Metals Company, or TMC. They are a Canadian corporation leading the charge to mine the deep sea. Their CEO, Gerard Barron, has a very compelling pitch. He says, look, the planet is burning. To stop climate change, we need to build millions of wind turbines and billions of electric car batteries. We need metal. Do we want to get that metal by chopping down rainforests in Indonesia for nickel? Do we want to rely on child labor in cobalt mines in the Congo? Or do we want to go to the bottom of the ocean, where there are no people, no trees, and just vacuum up these rocks? They call it zero-waste mining. It sounds great on paper, but the discovery of dark oxygen throws a wrench into the gears. When Professor Sweetman published his paper in Nature Geoscience in July 2024, the Metals Company hit back hard. They released a rebuttal accusing the study of being flawed. They claimed the voltage readings were errors and that the oxygen increases were just sensor drift. But the scientific community largely stood by Sweetman. The peer review process for a journal like Nature is grueling. They wouldn't have published it if the data wasn't solid. But the battle lines are drawn. This is all playing out right now in Kingston, Jamaica, at the headquarters of the International Seabed Authority, or ISA. This is a UN-affiliated body that has a nearly impossible job. They are supposed to protect the marine environment, but they are also supposed to manage the mining of that environment. For years they moved slowly, but in 2021, the island nation of Nauru, which sponsors the Metals Company, triggered a legal loophole called the 2-year rule. It basically said, if we apply for a mining license, you have 2 years to finish the regulations. If you don't, you have to let us mine under whatever temporary rules exist. That deadline passed in July 2023. There are still no final regulations. Now, everyone is looking at July 2025. That is the next big showdown. Countries like China and Norway, along with TMC, want to start mining. They say the green transition can't wait. But a growing group of nations, France, Germany, Brazil, the UK, are calling for a moratorium, a pause. They argue that we cannot mine what we do not understand. And dark oxygen is their biggest weapon. How can you approve an environmental impact assessment if you didn't even know the most basic chemical fact about the ecosystem until 6 months ago? The implications of this go way beyond the ocean floor. They reach back to the beginning of time and out into the solar system. We have always been taught that the Earth had no oxygen until cyanobacteria, blue-green algae, evolved photosynthesis about 3 billion years ago. That is the Great Oxidation Event. But these nodules have been around for billions of years. Could they have been producing oxygen long before life evolved to make it? Could they have provided the first little pockets of oxygen where early life learned to breathe? It rewrites the history of evolution. And look up at the stars. Astrobiologists are obsessed with ocean worlds like Jupiter's moon Europa and Saturn's moon Enceladus. We know they have liquid oceans under miles of ice. We know sunlight never reaches them, so we assumed any life there would have to be very simple, living without oxygen. But Europa is bombarded by radiation. Its surface is oxidized. If that oxidized material cycles down into the ocean, and if there are rocks, like our nodules on the seafloor, then Europa's dark ocean could be full of oxygen. And if there is oxygen, there could be complex life. Big life. The discovery of dark oxygen means the search for aliens just got a lot more interesting. So here we are at a crossroads. On one hand, we have the green transition. We need to get off fossil fuels, and that requires metal. The deep sea offers a massive supply. On the other hand, we have an alien world right here on Earth. A place where rocks breathe electricity and octopuses guard their eggs for eternity. A place that might hold the secrets to how life started. The discovery of dark oxygen is a warning. It tells us that our ignorance of the deep ocean is profound. We once thought the bottom of the sea was flat. We were wrong. We thought it was lifeless. We were wrong. We thought oxygen required light. We were wrong. If we proceed with deep-sea mining now, we aren't just breaking rocks. We are dismantling a planetary life support system before we even know how to read the manual. As the massive mining harvesters sit on the decks of ships, idling their engines, waiting for the green light from Jamaica in 2025, those nodules are down there in the dark, crackling with voltage, breathing life into the abyss. The question is, will we let them continue? Thanks for listening to G Fun Facts Online.